In this problem, we are given the following knowns. So we have the initial velocity of the aircraft, which is 0. We have the final velocity, which is plus 62 meters per second. And we have the acceleration, which is plus 31 meters per second squared. We are asked two things. We're asked the amount of time it takes for the aircraft to go from 0 to 62 with this acceleration. And we are asked the displacement of the aircraft during this time. So both of them we don't know. However, just on a side note, we kind of can figure out delta t. Since the acceleration is 31 meters a second squared, that means the velocity increases by 31 meters per second every second. So since 62 is 31 times 2, the amount of time it takes to get to 62 meters per second is going to just be 2 seconds. So that's just kind of off topic though, but we can just figure it out without kinematic equations. Let's go ahead and do it formally though with kinematic equations. So for part A, they want you to know the final or the amount of time it takes for the aircraft to get from one speed to another. So the best equation to use that has the unknown and the knowns is this one right here. Okay, and what we need to find is delta t. We have v final, we have v initial, we have a. V final is plus 62. Again, I'm going to leave out the units for simplicity since it's all SI units anyway. V naught is 0 and A is 31. So therefore, let's just plug and chug, do a little bit of algebra. Delta T is going to equal to VF over V naught. Sorry. Is going to equal to VF minus V naught divided by A. So plugging and chugging, that's going to be 62 minus 0 divided by 31, kind of as you would expect, because this gives you 2 seconds. There and done. For part B, it's a little bit more complicated. We're going to go ahead and, again, we have 2 seconds on our side, and that's just fine and dandy. But we're going to go ahead and use only what the initial conditions have or has been given us so that we can solve for delta x just with this. And it is possible, apparently. We got v final squared is equal to v naught squared plus 2a delta x. We want to find delta x. We know what a is, we know what v naught squared is, and we know what v final squared is. Well, v final is going to be plus 62. V initial is going to be 0. And A is going to be plus 31. Again, let's go ahead and reorder this to isolate delta x. That's going to be v final squared minus v initial squared over 2a. Plugging in all the knowns, that's going to be 62 squared minus 0 squared divided by 2 times 31. After you plug it into your calculator, this ends up being 62 meters.